Hello again. So this section is not originally part of the textbook, but I'm adding it here because in the section on arrays, we saw that variable length arrays are one mechanism by which we can allocate arrays whose size is determined at runtime. But as we also discovered, variable length arrays are not supported on every platform by every operating system or even in every IDE, and Visual Studio just happens to be one of them. Now, an alternative to variable length arrays, then, if you want to allocate or decide array sizes at runtime, is to use dynamic memory allocation. And we have a function for that called the Malloc function, which is short for memory allocate. So the Malloc function, what it does is it will allocate a continuous chunk of memory, and you have to specify the number of bytes that should be allocated here. The return type from the Malloc function is a pointer of type void. Usually what we do is we have to cast the pointer to an appropriate data type depending on what format, what data type we'll use to put data into that allocated chunk of memory. The function prototype for the Malloc function is pretty straightforward then. It's simply this. Provide in the argument the number of bytes to be allocated and receive in return a void pointer. Now, whenever you're working on a platform that does not support variable length arrays, Malloc is your best alternative. In order to use the Malloc function, unlike the other memory functions that you saw in this chapter, the Malloc function requires the inclusion of a separate header file, malloc.h. And I hope, as you by now understand, the benefit of having dynamic arrays is that you can decide, based on perhaps input that you receive in your program while it is running, long after you've already compiled it, you can decide how much memory to allocate to data structures. So the size of an array does not have to be decided, fixed, at the time you are compiling your program. And like I mentioned, this is very handy when the amount of memory that you're going to use for an algorithm, for a data structure actually, depends on certain inputs that you may receive from the program, and that may be different at one time that you're using your program, maybe different at another time that you're executing your program. And here's a simple test program that'll demonstrate that, and I'll show you that again in the hands-on section with actually a few more comments added in. So we have, like I said, we have the Malloc header file that we have to include. We are going to declare a size t variable called n, and going to declare right at the beginning an integer pointer called dynamic array. I think I use slightly different names in the hands-on in the demo section, but it's basically the same structure for the program. And then we print out a nice message for the user asking to enter an unsigned integer for that's going to be the array size. And we read that in using scanf's safe version, scanf_s. We read in that unsigned integer and store it in n. And here is then why we're here. This is how you use the Malloc function. And you can see in the argument over here, I'm remember the argument is in terms of number of bytes. Over here, I am using the Malik function to allocate enough memory for n integers. So how many bytes will that be? It will be n times the number of bytes used by my system for an integer, and I can get that number using the size of operator. So n times size of integer. That's how many bytes I need. And the return type from the Malloc function will of course be a void pointer, and you can see that is being cast to an integer pointer, because at this point I have now decided that I'm going to use this chunk of memory allocated by Malloc. I'm going to use this to store integers. So that's why I'm doing the casting right here. That's what this is. So the void pointer becomes an integer pointer. And that address is now assigned to the integer pointer dynamic array, the one that I declared up here on line 8. And so this is how in one line, in one statement, with one function call, you can, in effect, allocate and basically create an array of a size whose size is determined at runtime. And what comes after this is just simple demonstration of how to use such a dynamic array. And you can see I have a for loop over here that goes from 0 to n, whatever the value of n the user entered. And I increment this loop counter variable I by 1. And the first line inside the loop, I just write some value into the element of dynamic array, and you can see that accessing the members of this dynamic array looks exactly the same way it looks for a static array. So once you have allocated the memory for a dynamic array, using that array afterwards is no different from using a static array. And on the second line inside the for loop, we just print out the value stored in that same element of that dynamic array, and it's printed out with a space after it. So I'm just printing out in this for loop, we're just printing out all the values in this dynamic array on a line. And to insert a new line character, I call the puts function, and that's the end of the program. And let's see what the output from this program looks like for two different inputs provided by the user over here. So if the user enters 20, for example, then this is the output from this program. It'll initialize the elements in here to 10, 20, 30, 40, 50, 60, 70, 80, 90, up to 200. So that's 20 elements right there. If the user enters 10, so half of what we did the first time in the first run of this program, this will print out 10, 20, 30, 40, 50, 60, 70, 80, 90, 100.